So let's handle this issue with respect to new Swift.o syntax. And we're going to do that by basically setting up a new URL like so. And once we have our URL, this method actually can return an optional. We're not guaranteed to get a URL, so I'm going to force unwrap that, because if we're not able to convert the result of this function call into a URL, we're in serious trouble. So it's worth the danger of crashing if that fails, because if that fails, we're basically not running on a stable OS. Something is horribly wrong. And I'm going to modify these methods here. I'm going to call the URL NSURL version of those. So I'm going to say URL by appending path component. I'm going to pass in the key. And I'm going to do the same here. URL by appending path extension. I'm going to pass in the extension that I just made up called archive. I mean, you could set this to anything that you want. And down here, I'm going to say URL absolute string, because we are not returning a URL, we're returning a string object. We're going to get one warning up here, which is replace var with let, because this value is actually never mutated. And I'm going to double click to say yes, because that's a good suggestion from Xcode, and we appreciate it. So what are we doing here? We're constructing an archive path by first grabbing a string representation of the file system path to the documents directory, which is the sandboxed location that we can actually store data. I'm then converting that path into a non-optional URL, which is an instance of NSURL. I'm doing that so that I can take advantage of these path modification methods on NSURL, which are URL by appending path component and URL by appending path extension. This is valuable because I don't want to write data directly to the documents directory. I want to write it to a key-specific path. And I'm going to do that by basically saying, take the documents directory path and append the key to it as a path component, and then append the path extension. And we can set a breakpoint here to look at exactly what this looks like, so that when we run it, we'll hit that and be able to inspect it. But then I'm basically returning URL as an absolute string, as a type string. So I can set a breakpoint here. I might want to set a breakpoint here and here too, to see that let path is equal to something that I expect it to be equal to. So that's great. We might do Command B just to make sure that everything builds successfully, and it does. We have no warnings, no errors. And then the final piece of this puzzle is going to come back to come back over to To-Do List View Controller and say, instead of our user defaults cache, I want to use our keyed archiver cache. So I'm going to say keyed archiver cache, like so. So you can swap these out, or you could set up a more elaborate mechanism with a Boolean flag that you trip. But basically, let's run this thing and see what we get. So when load is called, so we're going to hit this breakpoint. If I step backwards, I can see, load is being called here. We're entering into the load function itself, which we'll call our cache's load object for key function, which is right there. We're going into the archive path method, and we'll see here local scope variables for URL. And if we print out URL, come on, buddy. Yeah, if we print out URL, it's going to abbreviate it, unfortunately, but it's basically going to give us the path to this particular directory with our extension on it, and it's truncating it here for frustrating reasons. And I imagine the same thing is going to happen here too. But if we expand it all the way, we'll see that path is actually this long path within the simulator, containers, data application with a unique identifier, documents directory, cache key.archive. So in looking at that, we know that we've constructed a path that is pretty darn good. So if we continue, we don't see that item in the list that we had last time we stopped, because we're checking a different storage mechanism for it where that item just doesn't exist, so we're starting from scratch. So let's add an item here. Add it. We now know it should be saved to disk. If we stop and we run again, we'll see that item come back. And let's actually take a look at that. Let's actually go to to-do list view controller in load, and we'll set some breakpoints here and here. So if we do run, when load is called, when this list is created, this breakpoint will be hit. We'll see that object in local scope is something. And if we step over, we'll see that items is also something, and it contains our initial to-do list item. And this is great because it means that we've actually set up a totally different storage mechanism using NS-keyed archiver. But both objects, both implementations, use defaults cache and keyed archiver cache, take advantage of the exact same protocol. So we didn't have to do manual work to make both of these things. We were able to set up a cache protocol which allows us to sort of provide as many implementations of what it means to be a cache, to store and load values. We're able to do that, and we've made 2 of them. So with that, let's move on to the next video. Cool.